So this is my video on finding the arc length of a curve 8.1. So let's see what we are trying to do. Okay, so suppose we have a curve. Now the curve can be a circle, an ellipse, parabola, anything, but a curved curve, right? So as to say, suppose you actually want to find the length of the curve along the curve, okay, along the curve. So this is now, clearly a problem that we can use integration for, right? Because integration actually deals with things, situations like that. And so how do you use integration for this? So integration we know is accumulation. So we know that if we can break this curve into small pieces, right? And we add the lengths of these small pieces, then we get the length of the big piece, or in other words, if we integrate the lengths of the small pieces, and then we get the big length. So let's take a small piece delta s, and then I kind of magnified that. And so I'm going to create a small triangle, although this is not a triangle, it's kind of curved. But if you think that this is small enough, if delta x and delta y are small enough, delta x is the x distance and delta y is the vertical distance, right? So if delta is really small, as we always assume in these cases, then we can kind of use Pythagorean to write delta s squared as delta x squared plus delta y squared. This is just Pythagorean because it's like a right angle triangle if you imagine this to be really small. And then we can factor out a delta x squared out. And if you do that, then this delta x squared is gone. So you get 1 plus, and then because we factor out a delta x squared, we get delta y over delta x squared. So basically we get delta y squared over delta x squared, but you can take the square outside and write it as delta y over delta x squared. And of course we factored out the delta x squared. And now if we take the square root on both sides, and we want to do that because we want to nail delta s, then we get the square root of this piece here times the square root of delta x squared is delta x. So that is the length of a small piece, one of the small pieces here. So then how do you get the big length, arc length? And that will be the integral of this lengths. So the integral of that would be the integral of ds. So what happens is then, because we are sending the number of segments to infinity, delta s becomes ds and delta x becomes dx, and then delta y becomes dy and dx. So basically this is what we have in the end, a formula. So if you want to find the arc length of a curve, we take dy over dx, we square it, we add 1 to that, and we take the square root and we integrate it. So that's how you find the arc length. So now let's do an example. So I'm going to do an example to find the arc length, and then using the formula we just kind of derived. Now the arc length calculations are pretty, I would say, lengthy, and the integrals are pretty difficult to evaluate most of the time. But so I took a carefully selected a function which can be integrated fairly easily, and the limits, even though they look weird, they were selected so that the integral comes out decent. So once again, the formula for the arc length then would be 1 plus dy over dx squared, square root dx, and the limits are from 0 to 32 over 9. So the whole idea is to find the arc length of this curve x to the 3 halves from 0 to 32 over 9. So when you do a problem like that, sometimes it may be a good idea to kind of go to a little corner and then work out the integrand. So we start with y is equal to x to the 3 halves. So first we find the derivative because we need that. So dy over dx then will be using the power rule. 3 half comes up in front, and x to the, you subtract 1 from 3 half, you get 1 half. And that is this inside piece. Now you need to find the square. So you square that. So when you square that, you get 3 squared, which is 9 over 2 squared, which is 4, and x to the 1 half, if you square that, you just get x, because x to the 1/2 is square root of x and the square root of x is x. So then that's dy over dx squared. Then the integrand, or what is inside, part of it, what is inside is 1 plus dy over dx squared, which is equal to 1 plus 9 over 4x. So when you plug that to this piece inside, you get 1 plus 9 over 4 dx, and you get a square root outside. Now all we need to do is to integrate this, and it's a very simple integral compared to the ones you have done. What you do is you put a u substitution. U is equal to 1 plus 9 fourths x, and then du will be then equal to 9 fourth dx. And then if you solve for dx, you get dx is equal to 4 du over 9. So 4 over 9, right? And then 4 over 9, and then square root of this is u, square root u du. So I'll do this very quickly. So this is the same as 4 over 9, u to the 3 halves over 3 halves. So let me bring it over here now. So 4 over 9, what is u? U is equal to 1 plus 9 over 4x. So 1 plus 9 over 4x to the power, and then you have 3 halves here. So 3 halves divided by the new exponent, just the power rule. Okay, so 3 halves. And now what you do is you just take this 3 halves, the 2 right to the top, and you get 8. 2 times 4, and then you have 3 times 9, which is 27. And then what you do is you put the limit. So the first top limit is 32 over 9. And when you plug that for x, you will get 9 over 4. Instead of x, you get 32 over 9. And you get 3 halves. And then when you plug in the bottom limit, which is 0, then this whole piece becomes 0, and you just get 1. So you get to subtract 1. Okay, so now it is not so bad as it looks, because we know that 9 and the 9 will cancel off, right? And 4 times 8 is 32. So really you get 8 from this situation here. So you get 1 plus 8, and you still have a 3 halves outside. Minus 1 to the 3 halves is 1. And outside you have 8 over 27. So inside you get 9 to the 3 halves, which is the cube root of 9 to the 1/2. Okay, so 9 to the 1/2 is 3. So, sorry, cube of, not cube root, cube of 9 to the 1/2. 9 to the 1/2 is 3. So 3 cube is 27. So you get 27 minus 1 times 8 over 27. So 27 minus 1 is 26 times 8 over 27. And that is your answer. So once again, what I did was I just took my curve, right, and I went to a corner and I found the derivative, because it's very easy to drop pieces here in this problem. So derivative squared, 1 plus derivative squared, and put that as the square root of that as the integrand. And then I just wanted to integrate this. Then after that is just finding an integral, okay, from 0 to 32 over 9. And in this case, we can put a simple u substitution. When you put substitution, it becomes square root u, and the integral of square root u is u to the 3 halves over 3 to the over 3 halves using the power rule. And of course, we have 4 over 9 outside, and we bring that in here, right? And then we go straight to put in the limits, and we selected the limits so that they cancelled out pretty well. Okay, so this is the answer. And thank you for watching.